So good evening, everyone. I would say we are almost halfway in this Excel for data analytics. So Tableau is still there. So I'm just talking only about the Excel data analytics part. So today we are in class 6. We are going to discuss some basic. So 101 introduction, you can think like that, of statistics. So we know what is mean, median, mode, spread, skew, some terms. We'll see how we can handle that in Excel. So that is the main part for today. I will do a little bit theoretical part maybe for the first 30 minutes or so. Then I will take into the Excel workbook and we'll do in practice. These are all some fancy terms, but it's pretty much easy only. All right. So today we are here. As I said, next week we don't have a class due to the spring recess for the school. We follow the same school pattern. And then we will be back on April 23rd, right? For further statistical concept, that is a linear regression and correlation. We'll discuss that. So this is going to be our today's learning objective, statistics. When you talk about statistics and inferential statistics, okay? We'll talk about descriptive statistics today, and it includes mean, median, mode, and range, and what is standard deviation, and what is skewness, and what is skew. We'll talk about that. And then to help understand all these better, we'll take this workbook and we will practice with 3 worksheets. I just have 3 worksheets for today. We'll do that. Once we're done with that, we will talk about a few project guidelines. Okay, I'll share a few more website where we can look for a project and data. All right. Mean, median, mode, spread, the standard deviation, and skew. And then we need to understand these 2 terms. What is population and what is sampling? All right. So let me explain one by one. All right. First, begin with understanding the word population and sample. Okay. Say that we are going to survey the whole population of Providence. Okay, all the individual household, we are going to survey that of whole of the Providence. Okay, like that. So this is the whole population, and practically it is not possible to do such a survey. Okay, the time constraint or budget involved in that. So usually what we'll do in that case, we'll go for a sample, right? Instead of doing individual 100% survey, we'll get the sample out of that. Okay, we call that as subset. Okay, UB subset, SET subset, and this we call as the population. POPULATIO. If you want to make a note, you can make a note of all these words. Okay, means I'm surveying everyone, including everyone in that survey. So that is population, the whole. If I take a subset of that population, okay, call that as a SEPLE, sample, sampling, right? Sample. So the 2 terms, population, sample. So if they ask in the interview, always try to relate with some example so that we don't forget and we can easily answer the question also. So what is a population sample? Let's say that if I'm going to for the whole of city of Providence, then it is population. If I take a sample of that, only subset of that is sample. So that is one example. We'll go with another example. Number 2. If I want to do a survey for all the students in United States, all the college going students in United States, right? So that is population, all of them. If I include, practically it's not feasible. So what we can decide, 500 in each university, which means I'm just taking the sample, right? So that will be the sample. Once we do that sample analysis, what we do, we infer some result out of that. Infer, notice this word, infer, INFER, infer. We infer something and then we project that to the whole data set, to the whole population. So we call that as inferential statistics. You take the sample, you do 100% analysis in that, whatever you infer from data and you are providing that result, doing that is called as inferential statistics. We'll be talking about this inferential statistic later. And then here to do the statistical analysis based on the population and sample, we'll be doing things like how the data is spread, how the data is dispersed. For that, we'll be using standard deviation. This is the Greek symbol for standard deviation. And there is quite a little bit formula for this. We use square root and then summation of x minus x bar. Don't worry, all this can be handled in Excel very easily, okay? So this is actually the formula, x minus x bar to n minus 1, okay? So n will be the total number of data set, and then this x, we need to find each data point. I will explain this again later. This x is the mean of all the data set. Once we get the mean, we know that, and we have to square that, and we have to do the summation, which means we have to add everything. And finally, we need to do the square root, and then we get the standard deviation. So this much calculation is involved, okay? So Excel made all the statistician, all the data analyst life very simple. All that we will be doing in Excel is just we type equal, and then there is a function stdev dot p. If you say p, which means you are doing a statistical analysis for the whole population. Instead of dot p, if you say yes, which means you are doing the statistical for the sample. All right. So this much, if you know about the inferential statistics and the terms like population, sample, subset, and standard deviation, you don't even have to worry about this formula because anyway, we are going to directly use this in Excel. So we call this totally of this sort of analysis as this sort of statistical is inferential statistics. All right. So today we just talk that much only about inferential. We are going to talk and practice more on descriptive statistics. Okay. So we are going to do that part today. So what is descriptive statistics? In descriptive statistics, we have mean, median, and mode. First, we'll start with a mean, okay? I have a few data points like this. Let's say 25, and then I have 30, and then I have 39. I'm just randomly entering some data points, okay? 50 and 75, and then let's say 98, okay? So 3, 5, 6, let me add one more, 78. So totally I have 7 data points here. I want to calculate mean, okay? So mean, E-A-N, the first calculation that we'll do in descriptive analysis. What is mean? How to calculate the mean? We add all of the data points, that is 25 plus 30 plus we include 39, we add everything plus 50 and then plus 75 and then 98 plus finally we have 78. So we add all the data points and then we divide number of data points 1, 2, 3, 4, 5, 6, 7. So we add all of them and then we divide by 7, and whatever the result that we get, that is the mean. If you closely examine this one, this is nothing but the average, correct? Average. AVE or AGE, right? So average. Do we have the average function in Excel? Yes. Equal. We type average and then we open the parenthesis. Let's say this is A, B, C column. We say A1 colon. Let's say this is G column. We say G1 close bracket. Hit enter. We get the average, right? That's it. We don't have to necessarily add all this and divide by 7. Using this function, we get the average. Average is nothing but the term the statistician are using for descriptive statistics is mean. So whenever you come across the term called mean, find the mean. What is the mean of this data set? Which means they're asking average. Okay? Just you find average. All right. So that is first point. So there is nothing more to discuss about mean, okay? Mean average of that given data set. So here we have a few numbers. We can just even, we can add, we can divide. But if we have a whole data set like 215, so practically it's not possible. We are going for this Excel function. All right. So let's look into the second one. The second one is median. All right. median. Let's talk about what is a median. First, let me remove all this.
50.
Yeah, question?
No.
Let's talk about median now. Okay. So, what median? If we stress that word and pronouns, we can get middle number. Median is nothing but the middle number. Okay. Just think that median is a middle number. Median. MEDIAN. What is median? Median is nothing but middle number. Okay. What is the middle number in this data set? Middle. That is median. But there is a rule for this. Rule number one, you need to arrange this data set, these data points, either in A to Z or Z to A. Okay. Either you have to arrange in ascending order or descending order before finding the median. This is rule number one. All right. Now let's do that. So what is the ascending order? Okay. So what is the least number here? 25. We'll arrange in ascending order. Okay. 25. What is next least number here? Of
Let's
course,
see.
30,
30.
right? 30, correct. Next is 39. And then anyway, I have put everything in
50.
ascending order only. 50, 75.
75.
Surprisingly, only these are
78. 78.
and 98.
98.
Awesome. Okay. So what is median? Median is the middle number of the data set.
Bunch, yeah.
All right. Let's strike this out, strike this end, strike this out, strike this out. We ended up with this value. This is the median of this data set. We remove the both extreme ends and then focus on the center value. All about descriptive statistic is central tendency. They used to say like this, central, CN. Note this point. Note this word, central, CNTRAL, central tendency, TEN, central tendency. Always descriptive statistics focus on the center point, trying to find the center value of the data set. All right. So that is median, the middle value. All right.
One question.
Go ahead.
If in the case there is no amount in the median because there are six number, what's the median?
Excellent. That is step number 2. Okay. Let's say if your data point, good question, Gina. Who has this? Gina, right? Yeah.
Yes, Gina. I'm Gina.
Awesome. Good question. Yeah. I was waiting for that one. Look for the data set count. Okay. 1, 2, 4, 5, 6, 7. It is odd number. What do you mean by odd number? You know what is odd and even, right? We know what is odd and even numbers, right? Odd numbers goes like 1, 3.
The list of grades.
No
Even
pay.
2, 4, 6, 8, like that, correct? If it is an odd number, it's very easy. You will get only 1 point in the middle, right? If it is even number, let's say that I have one more data point here. Let's say 78, 98, let's say 99, okay? I have here.
5.
So now let us eliminate both ends, okay? I'm eliminating this. So this, strike, strike. If I like this one, I don't have anything, right? So I am left with this 2 middle value. Add this 2 and divide by 2. This is median in case of even number. You got it?
Yeah, I got it.
Yes. So just remember median. First, arrange ascending to descending. If it is odd number, exactly you will have only 1 point in the center. You pick that point.
62.5. 62.5.
Yeah, whatever you're getting. So that should be the median value of this data set. That is median. Remember this. Median means middle number in the given data set or the data range. All right. So let's move on to the third descriptive function, mean, median. The third one is mode. So what is mode? Let's try to understand like this. Let me go here and pick some color. Mode. M-O-D-E. Mode. What is mode? Just remember this. M-O. Okay. Mode. Most. O-T-E-N. Most often. Remember this. Okay. Most often. To find the mode, what we have to do? I have to put one T diagram like this, okay? T diagram. First number 25. Okay, let me 25. How many times the 25 is repeating here?
One.
Only one. Okay. How many this is repeating here? 30. Only one time. 39. Of course, only one time. 50. Only one time. 75. Only one time. Same thing. 98. 78. 99. All right. So everything just have only one. What you say here, there is no mode here. So you say no mode here, or U mode, UNIFO or uniform. When we have a data set like this, and if we try to plot, right? So probably our data will be like this if we plot in histogram. Okay. So there is no mode. Our data will be look like this. Okay, which means uniform. Everything seems to be uniform. There is no mode. Okay. Let's adjust the data and then I will show you how the mode, unimode, singular mode will look like. Okay. This is no mode. I'm going to adjust this data a little bit. Okay. What I'm going to do, let me adjust this. I will use pick the same color. First, I will erase few data points. I will remove this. I'm just adjusting the data to explain. Okay. I'm going to introduce 25 here one more time and then 25 one more time. And then now you tell me how many times this 25 most often repeated data in this data series. How many times this 25 is repeating? 1, 2, 3. Correct? I'm going to type 3. Most often. So how many times the first digit is repeating? 3 times. Correct? 30, one time only. 25 we already covered. 50, one time. 75, one time. So 78, only one time. So which is the most often repeated here? 25. So this is only one mode. We call this as uni mode. Probably when we plot, you will get like this. So uni mode, only one mode will be there. Okay, uni mode. Now tell this scenario. I'm going to make one more scenario. Let me of them. I'm going to remove this 37 to 75, and then just I'm going to make 25. Okay, I'm going to make here 130. How many 25s are there? 1, 2, 3. How many 30s are there now? 1, 2, and 3. We have 3, right? Make it 3. Everything is 1. So now you have two modes, right? Of same count. 25 is also 3. 30 is also 3, which means you have 2. 2 means by. We can say by, right? By means 2. This is called by mode. Yeah, remember this mode, bimodal. Yeah, by O D A L, bimodal. If we try to plot this, probably it will be like this. This will be one histogram if you plot here like this. Like have 1 point here. So by means 2. Okay, by is we have 2 equal most often repeated items here. We call this by mode. Let us repeat. Unimode is only one. Okay, bimodal 2, exactly 2. What would be the other one? Multi-mode. Okay, multimodal, more than 2. Let's say that I made one more 50 and another 50 here. Okay, one more here, which means what? I have 1, 2, 3 50s. Okay, so 3. Then 3 numbers that have equal count. 3 times 3 repeating. Most often 3 values are repeating with the same count, which means multimodal. I don't have to do this T diagram and count everything, right? If I have some 500 values, if I just input in Excel, it has to do that for me. Okay, what is the function for that? Equal type mode dot single. If you are sure it is only a single data, single mode, you use the single. If we feel it is a multi, it has more than one mode, we will type mode dot multi. Okay, don't worry, we'll deal all this in our Excel workbook. Okay, mode.t. Just grab and put everything in this function. It will result to you like this. It will tell, hey, in this data set, you have 25, you have 30, and you have 50. Like that, it will tell mode.multi. Okay. So we have a function called mode. All right. So what we discussed so far, mean. Mean is not average. Then we discussed median. Median is the central value of the data set, correct? It is a central value. There is a two rule in that. First, we need to sort either ascending or descending. If it is an odd number, just go for the middle data. If it is an even number, add the middle two number, divide by 2. That is median. Mode is often repeating data in the data set. So that is mode. Good so far? We'll
Yes.
see next. Next is spread. We'll look that later. And another one is skew. We'll look in that in another spreadsheet. Okay. All right. So median mode. I will include one more thing. Range. So what is range? We'll talk about range. Okay. So what is range? Or A-N-G-E. This all comes under the descriptive statistics. Okay. What is the range of this data set? Which means max
And the mean.
minus min. The difference between max and min, that gives you the range. We know the function for max. Unfortunately, we don't have a function for range in Excel, even in 365. Okay. So to calculate range, we need to use this one. We have a function for max, correct? We have the function called max. What we'll do, we took max and then we open bracket, we put all the data inside that and then minus, we've called the function min and then put all this data inside that and it will automatically calculate and it will result you one number that is called range. So in this case, what is the maximum number here? 50, right? 78. 78. So what is the minimum number in this data set? 25, right? So 25. So 78 minus 25, you will get that as a range. So what is a range? Max minus min. That is range. Remember, we don't have any function in Excel to calculate the range for the descriptive statistics. We have to utilize this max and min function. So that is range. All right. So with this idea, let's into the next slide and see our understanding. Okay. Let's see how our understanding is. If required, we'll again review this. All right. So mean. So mean is also known as average. The mean is found by adding all the given data and dividing by the number of data. So that is the definition. And then median. What is the median? Median is the middle number. You can think like this I, okay? Middle number. Median is found by arranging the data in order, either lowest to highest or highest to lowest, ascending or descending. If it is an odd number, then center one is the median. If it is an even number, find the of the two center value that will give you the median. What is mode? Most often occurring number or a data points in the data set, that is mode. The mode is the number that occurs most often, right? And then what is the range? The difference between the largest and yes, max minus min. That will give us the range. All right. Are we ready now? If you want free to use the pen, calculator, don't use Excel, just like math, okay? You can use calculator, okay? Shall I put data point here? All right. So this is the data side. Tell me what is the mean of all these. Take your own time. Just calculate. If you know the answer, just put that in the chat, okay? Mean. Let me give the clue. You need to add all of them and divide by total number. So what is the mean?
14.
14. Excellent. How about median? Rule number 1. Sort it ascending and descending. Look for the data. Oh, thanks. Already it is sorted with ascending order. So second rule, is it odd or even? What is the middle value? That is median.
10.
No,
10.
12.5. 12.5. Yeah.
Because this is even or odd. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is a odd number. So we want to go for the middle to add, divide by 2. That gives 12.5. Perfect. What
Why
is
mean 14?
Yeah. Mean is 14. Correct, Azil. Mean is 14 and median is 12.5. What is mode? What is the number that most often repeating here? Most.
10.
10.
Mhm.
What is the range? What is the
20.
formula?
20.
Max minus min, 20. Very good. So
25.
let's
Oh,
go with
20.
one more data set. Oh, mean means range. Range is minus 25
Oh,
minus
20.
5. Yeah, 20. Right. Go with one more data set for this data set. Okay. What is the mean? Yeah, some big. Okay.
30. 30.
Quick. So
30, right?
great. Okay. Go ahead.
Median, 25.
Here you have to.
25.
No, rule number 1.
Is 25.
Did you sort it?
Ah,
Ascending.
yes. You need to. Yes.
30. No,
Yeah.
You need to. Yes.
30. 30.
Just put in ascending order and then tell what is the middle number.
30.
30. All
Yes.
right, check. Perfect. So what is mode here? Number that repeats most often.
There is
mode.
no mode.
No mode.
No. Awesome. How about range?
25.
40.
Oh, no. 30.
40.
No
No,
mode is
40.
also no is also called as uniform, right?
40.
Uniform. Okay, 40. Correct. Max minus min 40. All right. So now let's talk about frequency distribution. How our data is distributed with the frequency. Let's look into that one. So statisticians use descriptive curves to visually represent the frequency of the data set, right? So all that we do in visualization is we try to project the data in visual format, right? So far we projected the data in a column, pie, bar. That's what we did, right? So now we want to go with another chart called as histogram, how we can visually project the data and analyze how frequently certain is repeated. Okay. So we use that one. Let's say the IQ of this class. We call this as, so whenever you plot the data like this using the histogram, okay, when you get shape like this, like when you, sorry, it went over, right? Whenever you plot, when you get a that this is the plot data that we plotted, okay? And all that we have to do, we have to run a smooth line that touches all the data points, okay? So whenever we encounter a curve like this, smooth curve, right? We call that as a normal distribution, okay? We call it a normal distribution. We call that as a bell curve also because this resembles like a shape of a bell, right? So we call that as a bell curve or normal distribution. If you see, this is a mode, right? So this is uni mode, right? See, only one point is there at the top. So it is a uni mode. Then the median is also here. The mode is also here, will be here in this case. So mean, median, mean, everything will be at the same point. If that is the case, then we'll get the perfect curve like this, which is a normal distribution. In normal distribution, the mean, median, and mode are all at the same point. Okay, so just note of that somewhere. This will be some sort of interview questions. Okay, in normal, the mean, median, mode all will be meeting at the same point, center point. All right. So now let's talk about, we talked about standard deviation, sigma. Let's talk about skew. What is skew? S-K-E-W, skew. They call that a skewness. Okay, what is, we remove that skewness, that's skew. What is skew? Just remember this word, symmetry. Okay, symmetry. Symmetrical shape, Symmetrical, right? Symmetrical shape. A cylinder, a perfect is a symmetrical shape. Why? If I cut this into two half, I have not cut it into properly. This portion and it will be equal. That we call as a symmetry, right? Human beings, we are a perfect example of symmetry. If you draw a line like this, left one eye, right one, left one hand, right one hand, we are a perfect symmetry object, right? Human being. Oh yeah, symmetry. Human perfect example, symmetry. If we add a here, asymmetrical. Whenever I plot something in histogram, okay, when I get smooth line like this, after I plot the histogram, when I get that line, this is a perfect symmetrical shape. We call that as normal distribution. No doubt in that. Whenever there is something skewness here and there, we should give some name for that. So they call that as a skew. Let's see some example for skewness, okay? Let's say I'm plotting, remember the examples so that you won't forget the things, and then it will be very easy to answer in interview also, okay? All right. Let's say that we have like this, asymmetry, skewness. Let's say that when I plot, my data point is like this. I mean that like this, it goes like this, okay? Here I have the mode in the histogram. This is my mode. And then here, let's say I have the data points here like that when I plot. And then here I have something, and then it goes like this, like this. Here we know this is mode. And let's say that this is and let's say that somewhere median is here, okay? Median. This is if a shape like this is right. This is 0 in the graph. Let's say this is something like 40, and let's say this is something like 60, and then 80, 100, 120, let's say 140, 160, and 180, okay? 180. And here it goes -1, negative side, right? -40, negative like that. So this is positive side, right? Positive side. So when we call this as a tail, see here, like a tail of the mouse, the statistician call this as a tail. Whenever you have a tail over the positive side, they call that as positively skewed. Positively call this as the shape, okay? If you see the shape of the visualization like this, then you say, oh, it is positively skewed because the tail is towards the positive side of the data point. You have to look for the tail. Okay. How I can remember this? Remember just one example, don't forget, okay? Remember wherever the data point you take of the income of the people in any country, when you try to plot, exactly you will see like this only. Most of the people will fall in this category. Most of the people income will fall in this category. You will see a lot of people's income range is this people. Most of them 60, 80. You can see rarely you go here per annum 180 getting people. Very few. 250. Just I'm giving example, okay? If you give the income example, most of the people get into this category. And slowly reduce. And then you can see well-to-do business people, maybe 250, 750, billionaire. It will go, if you go here, very tiny, right? So most of the population will fall under this group. So the income example is best example to explain the positively skewed. So that is skewed. Whenever the data is asymmetrical, we call this one skewed. Okay. What about the next one? You would have imagined, right? When the tail is this side, negatively skewed, correct? Yeah, we'll one more thing for that with some example. First, let me remove this. Yeah, write this income example best for positively. When in the interview, just give this example. That should be fine. Okay. All right. So now we will see one example for negatively skewed. Let's go here. Maybe I can extend this a little bit. And then how the negatively skewed will look like. It will start like this and go and then like this. Yeah. It will go toward the negative side. As I said, 0, negative 20, 30, whatever, -1, -2, like that. And if you plot, it will be like this. Okay. Say that this one as 65, and let's make this 70, and then let's put this 60, 55, right? 55, 60, 70. Okay, 55. I'll make this a 50. Okay. So what will be the best example? So this is moving toward the negative aspect, right? It's skewing, it's this side. So we call this as negatively skewed, negative, okay? Negatively. The example for this retirement age, okay? If you call the person who are retiring in any place, okay, retirement, you can see most of the people are tend to retire in 65 years of age, right? And then you can say, only few people say, oh, I'm done. I'm going to retire. I have made enough money in my life within 50. So I'm going to travel around the world, like 50. Very less people you can see in this getting retired. But almost most people after say 65 only, they will plan for the retirement, right? After 70 like that, okay? So negatively, positively skewed. So once we plot the data point, So if you get a kind of this way, you can just looking at the data, you can conclude about the whole data, about the idea of what that data is talking about. Yeah, what is the behind the data with this picture. So for that, we should know how to read and interpret charts like this. Okay. Yeah. So we get to know a lot about this as we get along in this practice. Okay. We have more practice workbook. We'll get to that. So let me see what is next. All right. Skewed. Okay. Skew data. If you see here, you can notice that no skew, right? So perfect. What we call, if this is like this, a bell shape or a normal distribution, right? It distributed normally. So we call this as a positive skew. Why? If I draw a smooth curve here, the tail goes towards the positive side. We call this a positive skew. So long tail towards this side. And then we call negative skew because the tail goes to this side. So long tail goes this side, negative skew. And then, as I said, symmetry. Symmetry means 50% of data this side, 50% of data. This rarely occurs, okay? In the mean median mode will all lie on the same point, okay? In this, you can see this is mode. The mean is away from the mode. So this is mode. Here, the mean is away from the mode. So normal distribution will exactly look like this. And then if you want to talk more about normal distribution, just add this word. In normal distribution, mean, median, mode will be same. All will lie on the same point. Positive skew, okay, towards this one. The tail, talk about this tail. Negative, talk about this tail. All right, so now let's play and see what is our understanding. Okay, first one, this data, just let me know what is the mode of this one? How many modes are there? And what is the name we can give for this one? The first one, just imaginarily draw a line, 1, and then somewhere here 2. In terms of mode have 2 modes, right? 2 means bi. So bimodal, right? We have 2 modes of data here. One set of data, another set of data. We see 2 peak point here, 2 mode. 2 means bimodal. How about that? Don't think of in terms of model, think about the distribution.
Symmetric.
Symmetrical.
Excellent. It's symmetrical
Normal
distribution.
distribution.
Yes, you can also call us normal distribution, and you can also call this is a bell shape. All right. How about third one? Just draw a smooth line.
Positive.
Excellent. That goes towards the positive side. So it should be positively skewed. Or as it moves to the right side, you can also say right skewed. Okay. It's skewed to the right side. Right skewed or positive skewed. Okay. How about one? Is there any mode here?
No.
No mode. Means there is a name for that. Uniform, right? Uniform. How about one?
Negative.
I all got the concept. Yes. Negatively
Negative skew.
skewed
No,
or
let's-
left skewed. It's moving towards the left hand side, right? So left skewed. All right. So now what we want to do, we want to grab this statistic XLS workbook and we want to practice what we discussed theoretically. Okay. Good job. Very nice. Sharing this practice workbook with you all in Google Classroom. Here we have 3 sheets. The first sheet will calculate the mean, median, mode using the Excel functions. And then we'll look into some practical applications, one with the race times data set and another one with the US president's data set. Okay, first now try to apply the descriptive statistics. Looks like a sports game and we have players here and the season it's conducted and the team name and everything. So we are interested in this particular column K, PIM. We have the data points here. So the instruction is, let's find out some basic statistics about the number of PIM means penalty in minutes for the top players. Whatever the penalty that has been incurred for the top players. So we need to calculate mean for these data points and then median and then all the other things. Okay. So let's first how we can do that. Mean is nothing but average, correct? So average. So let's go for the average. And then I can go here and then I can select all the data points that we want to calculate and then press enter. We get the mean. And for the median, we can do the same thing, equal. We have the function for median directly. You remember we arrange that in ascending to descending and we look either it is odd or even. No, we don't have to look that. Excel is going to do all that for us. See this much data points. We can't sort or do that manually. So we press enter, we get median. So the median of all these data point is 35. If you notice, every time I'm typing equal and going and keep on selecting the range, correct? So is there any way to avoid that? You remember in MOS, we discussed about define name the range, right? So we can define the name range and then every time instead of selecting, we can call that name, correct? So define name range. So we'll utilize that here. So we don't want to repeat every time. So what you do, we just select all the data and we know how to systematically do. We have to go to the formulas and we have to go to the define name, or we can type that in the name box, right? Alternatively, what we can do, select the data points, then just right click and then define name. It will bring the pop-up window and it will, most of the time Excel will suggest the name for us. See here, it is suggesting the same penalty in minutes. Okay, that's totally, I'm going to accept that. Or they suggested to give a name called penalty. Okay, I will get penalty, penalty. Let's go here. Select the range from K2 to K21. We completed that. While it's selected, go to the name box. I have to go here to the name box and I have to type penalty and that is ready. Now I have to call that penalty everywhere. So let's check that. Now my active cell is here. Let's go to the name box and select penalty. Yes, it's selected, right? I have included all the ranges. Now let's perform the calculation. Equal average. So what I have to do now? Penalty, correct? So my data set is called now penalty. So enter, I got that. So next one, median, equal median penalty, correct? If you want to do range, I don't have a range function in Excel. See here, if I type range, I don't find that and we don't have alternate for that also. So for that, we're just looking for the maximum, okay? So what is max here? Penalty, same thing. Every time we call the same data set, 87. What is the minimum? Correct. Okay, now range is what we discussed in theoretically. Range is nothing but max minus min, correct? So we click here. Max already we calculated max, negative, min, enter. We got the range. And what is mode? So we have a for mode,
Most.
yes. Let's say that if I'm sure there is only one mode available, I can go with a single, but I don't know how much is that. So let me go with always multi-mode. There is more than one mode, it will display everything. If it is only one mode, it will display only one. That's totally fine for me. So mode.multi, press enter. The mode here is 26, which means 26 occurs more than once. All right, we did some few descriptive statistics. Now let's move on to this one, count. Count also includes in descriptive only. Count equal, we want to count all the numbers there. How many numbers are there? Penalty, enter. So now I want to use count, but with some condition. Count if only for the penalty in minutes that is greater than 50, right? That should be greater than 50. So let me do it here. Equal count if
Range.
the range is penalty, that's correct, exactly correct, comma, what is the criteria? Greater than 50.
Greater
What is
than
the symbol
50.
for greater? So this is greater.
It's a yes.
Greater than 50. Do I need to put double quote for this greater than 50?
No.
No.
No, with no, and then press
Yes.
enter. Oh, it's throwing some error for me. Okay,
Yes.
I don't says error, so I put double quote. Anyway, if
Yep.
I get answer, that's fine. I got the answer.
Yep.
Fine. All right, let's discuss. I'm noticing this always in our class. When I should put double quote or when I should not put. Now it's the right time to discuss. You remember we discussed about the data type a lot of time, right? So greater than 50. Just notice if I just type 50, the number 50 is aligned toward the right side, which means it's a numerical data. It considers this as a numerical data. Whereas when I add greater here, what's happening? It's aligning towards the left side. Now Excel is treating this as a special character and a combination of a number as a text data. Correct? So for a text data, we always include double quote. That's what we did here. Yeah? All right. So if we have certain doubt like that, what we can do, we can always go with the function method also. See here, go to the function dialog box, and here it will open. So range is that penalty. And then let's say that I don't know if I need to add double quote or not, right? It won't say anything. Just go back and click, it will add for you. And then click OK, it will add. All right. So with this idea, let's look into some real-time example. Okay, let's go in this sheet, race times. Here we have some details about the runners. Okay, I'm not if this is a cross-country runner data or a half marathon runners data. Here we have some first place of that runner, and then their bib and the name of the participants and the gender, city, state. We have clock time and the chip time we have, and the pace they maintain throughout their running is measured here, 5.47, and the age of that person and all the details. Okay. So here we're interested in doing the same thing for mean median mode, but once I share this file, you can play around this one. Okay, you can play around using pivot table or whatever you want. Nice data set. We are going to do the same descriptive data set, same thing that we did, mean, median, min, max, range, and then same mode. But one additional thing that we want to do here is standard deviation. You remember the huge formula that I displayed, square root of summation of x minus x bar, all those calculation will be instantly handled through this function. If it is a population, you have to type P. If it is a sample, yes. You got it? All right. So now what we want to do, we want to find the mean for everything. Same thing, every time I don't want to select all the way to the bottom. So I use the age and then define this one first. So let's go and select all the data points. We have almost 1,000 runners participated in this maybe half race, and we have all of their information. Let's select. All right. We have almost 1,340 runners. Okay. So let's click and then define name for this selected data set. And Excel is telling me, hey, your column name is age. Shall I go with that? Yes, please go ahead. Okay, I'm saying do that. So now I have a name for that. If I go and see in the name box, if I select age, that is selected. That's totally fine. Let's do this really quick one by one. Let's go here. Equal mean means average, right? So we go with average and then age, double click, press enter. So this is the mean age. Let's go with the median, equal median. And then again, we go and type the data set age, press enter. So what it says that of all the players that are running, maybe the least age of the player may be 14. The maximum age of the player that's running may be 78. So what is the median in that? The age 34 group of people who was running in that marathon is considered as a median. Say, we are doing the central, we are going towards the center of the data. Yeah, the 14 and 78. But I am interested in finding the what is the mid sub. Then I get some idea about the whole data set. Oh, 34. Or maybe this side some age group are there, right? Moving toward the central tendency. All right, now let's go to the max age. And then see here, the maximum age of all these 1,000 runners, the maximum age is participant is 78 years age, right? Let's go with the min and see the least age, who is the minimum age runner. We are curious in that, right? Let's see that. We have years, right? And then what is the range? What is the, see here, now we take the least and the max, and then again we are trying to go toward the center of the data. Okay, so that range, see here, max minus, sorry, I have actually typed the minus sign. Let me bring the max again. Equal max negative min, enter, 64. This gives me the range. And then standard deviation, right? So I know I have all the runners. So only there are 1,000 participants and I have all the data. So this is individually We have all the data and the everything is recorded, the chip time, clock time, everything is recorded. I have not excluded anyone. In this case, I don't need to go for sample, right? I have all the information, but still I want to show you how the both works, right? So what slight deviation we are seeing, I want to show that. So let's go with the C here, stdev.p. P is population. Let's consider the whole we surveyed, okay? Yes, actually we surveyed the whole only, okay? And then age, press enter, and then let's see the sample. Let's say that I don't have all 1,000, someone just dropped out. Let's go with the std sample, and then same. You can see only a slight difference after the decimal point, right? We can think like we can ignore, but this makes a lot of sense in the data world data. So 888, so there is a slight difference here, but not that much in this data set. All right, we go for the mode equal. Always it's best to go with multi. I don't know how many modes are there. And then let's feed in the age data set, press enter, 22. What this conveys to me, what this speaks to me, of these 1,000 participants, there are a lot of runners whose age is 22. Everyone got this point? So that's what this describes as descriptive statistics. Of the 1,000 marathon runners, there are this time we see a lot of 22 years age people running. That's how we speak, right? So we speak through data now. All right. We go with one histogram for this one. Okay, create of the ages of the runners. Let's do that. Let me go with 100. So let's do this here. Histogram. We select the data including this age. We want to see how this data is dispersed and what is the frequency, right? Frequency means how many are in this age group. We want to see that frequency. So let's go to the insert, and then we clearly know what we want to do. We want to go with the histogram, but see, let's see any recommendation is there. See here, it already suggests the histogram for us. This is what we are going to work, and then click OK, and we have histogram. Just select and position it, and then just we'll align the little bit. I think this should be okay. All right. Now, when talking about this histogram, we will concept called bin size and bin number. So bin size means how many I want to put in one bin. Okay. In one, how many I want to put. That is bin size. Bin number means how many number I want. So this we want to determine. If you notice here, it is taking this automatically, the system is taking like 14 and sound. That doesn't make sense, right? 17.8, 21.6. So what we do, we just double click this one. And then if you notice, it takes automatic to make it more readability. So we have the width as 3.8, right? So 3.8 is somewhere closer to 4, right? So what we can do, we can make this as 4.0. And then the number of bin is getting adjusted to 16, and the width now is 4. So we have 4 people, each group 14 to 18, 18 to, and it's always up to us what we want to have. Let's say that I want to tell the story like this, considering the least group and the extreme end group. So what we do, we go with this group. If you want to modify, you can still go with the band with bin with 5, and then number bin you can increase. We can do that. So for now, let's go here and see how this looks. Now we can tell that we have 20, we are noticing here 21 young participant whose age are 14 to 18. And we have one participant age is 74 to 78. And we know through the descriptive analysis, we know that he is 78, right? Here we get to know somewhere 74 to 80, but here it describes very clearly that that person's age is 78. All right. And then what is the age group that we have the maximum number runners here?
26 to 30.
Yeah, almost like to 30, right? We have the maximum. Anyone would like to talk about this data point? Let's assume that you are going to give the presentation. So whatever I said now, we have the least runner here, we have the 78 here, and then whatever you want to interpret and talk about this data. Looks like, imagine you are going to give a presentation kind of thing. Anyone like to talk?
Okay.
Yeah, go ahead.
Also, this is a right skew. So it means that this is a positive.
Vinicia, I was just expecting that. Thank you. Very nice.
You
Yes.
also mentioned about we already know that the age is between the 26 and 30.
Mhm.
And that this is a right skew. It means that
The tail positively skewed, correct?
yeah, but the median. So it means that can you please go to the top?
Top.
Yeah, it's just to see the names. Okay, because it's the mean, it's not the median because of the visualization.
Perfect. The mean is the median and mode is not one and the same. Perfect.
Yeah.
You catch that point and you reiterated the tail that goes towards the positive side. We can call that as a positively skewed or right skewed. Perfect. This is a very nice technical. Now, I want one person who want to talk. Say, Vinicio speak as if we are all data analyst person. So we all understood what he talked about. He said, see, the mean and median and mode are not equal. We know what he mean by that. He said it is right skewed. We know what is that. Now imagine that you are giving this presentation to the audience who is not technically sound, who don't anything about mean, median, mode, right skewed, just you want to talk about to that audience. So anyone coming forward? Shall I pick one? Yeah, just give a try. Just talk in terms of normal thing. Anyone? Oh, in this marathon, this as if you are talking to your colleague. You are watching that marathon race, and then you are talking. Oh, in this marathon race, right? I saw one person who is like that. Something. I saw some around 20 persons running with the age group. There should be somewhere around 14 to 18 only, like that, right? I want that kind of conversation. Can anyone tell such stories now?
Oh,
Yeah, go ahead, Alba.
podríamos decir que sorry, I forget.
No, perfect.
The majority of the participants were in the range of 26 to 30 years old. It was the streams was the oldest was between 24 and 28 years old.
Okay.
No,
The least that we see.
and this is like
yeah, you can.
there
Perfect.
was 21 participants between 14 and 18 years
Okay.
old.
Yeah. Yes. One more thing. If you adjust the bin size, right? If you put 10 people in one group, and then the entire story will be a slight different. Okay. All right. Now let's get into this data set. So we'll do this one. So this is one interesting data set. Here you can see the name of the presidents here, George, and then we have all the president info here, their birth date, and then the age at which they started first presidential, the term. Okay, at what age they started their presidency term, and then the age at death. Okay, so we have these two information. Let's find analysis using this. As usual, we want to right click and then define name. We will go as per what the Excel suggests. It suggests age underscore at underscore. Yes, we accept that. Similarly, we'll create one more define name for as well. So right click, age at death, that's fine. We click OK. All right, so now we have two data sets. So now let's calculate the mean. Equal mean means we know its average. And then what is the age of the term? So press enter and then median equals median start of the term, press enter and then standard deviation. STD, equal STD standard deviation for the whole population, in the sense for the whole data set we consider. Both are same only. Here we don't have the sample, but still I want to try both the function. Okay. I'm going to age at start of the term. This gives the standard deviation. And then we go for the STD sample. We go with the same data set, and then age at start of the term, and then press enter. So we get two modes here, correct? So most of the president took their presidency at the age of 54. We see most of the president like that, and 51 too, right? So this gives mode. And then let's work this mean as well. The death also. Age at death, and then equal median age at death, and then STD equal STD age at death. Press enter. And then ST equal standard deviation sample age at death. Press enter. And then let's see if this has multi-mode, mode.multi, and then age. So we have only one uni-mode here, okay? So 60, almost most of the presidents seems to be died at the age of 67. So multi-mode, okay, 67. Mean, all right. So now let's get into the histogram part. Let's click here and let's select the whole data set. And then let's go to insert, and then we'll pick the histogram, and then I'll just leave as per the default bin size and everything that Excel automatically generated. And then we create one more histogram for this as well. We go to insert and then histogram, and we rearrange this and reposition this to this location. Okay, we can add a chart title. Okay, age presidency, age of the president, who start and then age at death. We can do that. Maybe we can do one more thing. We can just add the labels. Okay, so data here also select and add the data labels. That's totally fine. And then here we need to fine tune this. Look, this is okay, I see, right? 46 to 60, that seems to be okay. But here 49.3, so that automatic don't seems to be working. So let's go to bin. And then it's 7.3, right? 7.3, which is not more than 5. So maybe we can make this a 7.0. And then let's see, 5. Yeah, that looks okay. Let's see this one. How many? 4. I think that should be okay for this case. All right. So here, if we notice, most of the president, their position at the start of term, right, at the age of somewhere 48 to 54, we see 15 presidents. If you want to see how many presidents are still younger, yeah, young presidents, we have almost 7 presidents whose age around 42 to 48. And then we see one president whose age somewhere around 72 to 78. Do we calculate max min here? No, we have not calculated. If we have calculated max, we would have found out what is that age, right? Yeah. So it's Joe Biden, right? So Joe Biden, 78. All right. So you can see here, Donald Trump. So first presidency is at the age of 70. So this data set don't repeat it second, right? Because we are plotting only for the first time they took the presidency, right? We have one more president like this here. Let me see if this person, Grover Cleveland, right? So he got his first presidency at the age of 47. Then following the Benjamin Harrison, then again he took the presidency for second term, but we just interested only at what age they took at the first term, right? So we have not the duplicate data, and here also we have not included the second term presidency. We are considering only for the first time the age when they took the, okay. And then you notice the age at that, we see most of the United States presidents, the age somewhere around 60, like that, right? So what is the bin width here? Almost 4, right? No. Maybe we can try to adjust this one. Bin width will reduce, right? This is 14 it is taking, right? So maybe we can play around this. Let's say if we can give some 10 interval and see how it works. See here, now the story completely changes. This is like a trial and error method, how finally you want to talk about that story. So now I would like to talk about like this, right? Like this, you can modify, adjust, and see this. I go with this story because I can say one president lived over 100 years, right? One. Before it was not like that. This one also put into another group, right? So now this one has been excluded from that group, and I'm glad. Oh, one person lived up to 100 years. Okay, who is that son? So Jim Carter, 100. Yeah. Jim Carter. So it's better if we can capture the min and max also here, but I have not included. But when I send this workbook, maybe please you can include the max, min, and range also here. Max, min, and range. Okay. All right. So it's something about the frequency distribution of data and how we can project the data using histogram, and we can analyze, and then we can talk about this. Chart is a statistical tool. Okay. Histogram is one of statistical tool, and we have 2 more tools chart to discuss. We are going to take that in the next class. Okay. Scatter plot, discuss that in the next class. It comes under the linear regression and correlation analysis. That is going to be our next topic. All right, let's see what we have still today. We have some 6 minutes. Let's finish. All right, so this is the workbook that we worked now, and then let's go here. We'll look into some project guidelines, okay? Nothing, just a brief introduction about the projects, okay? Almost we are in all this area of today, right? Everyone agree to that? So we know how to pose a question, collect, or if the data is not correct, clean, we know how to clean it. We know primary and secondary data difference, and then how to visualize. Basic chart we know, column, pie. And then today we looked into one statistical significant chart, that is histogram. Okay. And then how to analyze and interpret data. We today saw one real example, how to talk to a technical person and how to talk to a non-technical person when you give a demo. Okay, you take an example of Vinicio, the way he talked about this, because he knows we are all statistical person, we are all business analysts, we know data. So he talked about the technical terms, and the mean median mode is not equal. So that is why here, and you can see the tail is skewed towards the right. So he used all the technical jargons, and I volunteered someone to talk about the non-technical term. Then Alba came forward and she gave a nice explanation how to address these findings to a non-technical. We should know both, right? You should know both. That is the perfect example. All right. So let's move on to the next slide. So what is the objective of the project, that why we are to work for the project, right? The objective is to formulate and answer some research question. You can use either primary or secondary data collection method. And then you will create the data analysis workbook using Microsoft Excel workbook. You can work individually or with your team. Okay, if you want to work with your team, just talk to us. We are partners, we want to work like that. And then your topic can be any subject where insights can be gained from analyzing the data. Okay, each individual will have, if you're individual or a team, you will have some 7 to 10 minutes for your presentation. Okay, for now I'm saying 7 to 10. We will decide. Okay, once you project phase, if you feel that 10 minutes is not sufficient, then we make this as 10 to 12. Okay, we can put that. And then during the project presentation is on April 30, but before that we have a lot of rehearsal in our class. Okay, so we'll lot of things we'll review and we'll do that. So the project should incorporate BI model. You know what is organizational data intelligence model? So the same story here. And then let's move on to the next one. And then the the presentation should explain the process, research, data collection and cleaning, and how you standardize that, visualization, all those things. And then the things that you learned, observed in the class, if you put that as your project, that should be totally good. We don't expect you to come up with some other thing that is not discussed in the class. Okay, we really expect that, and we don't really need that. So whatever we discuss in the class, what you captured, what you observed, if you present that, that should be totally good, totally fine. Okay, so you can include a pivot table or whatever the statistical concept that we learned today, and we are going to learn about regression analysis method in future class. And then you can think about including the conditional formatting, anything, right? All right, here are some public data portals where you can look for the data set. And let's go here. So this is the learning summary for today's objectives. So we discussed mean, median, mode, range, standard deviation, skew, and we worked on this and few project guidelines. I will send this tomorrow to you. Please make a moment to download and look into that. And let's go. Okay, before we next class, so we have enough time, right? I'm not going to meet, we are not going to meet next week. So we have enough time. April 21 only we are going to build linear regression. So before that, you download the statistics and try to practice. That should be totally good. And then the public data set that I shared in this previous slide, take a moment to visit all these site and see if any data is interesting for you. Okay, you can health data, right? You can do that. And then I have two video here that explains about the pivot table. Okay, anyone who has not attended the level 2 program, if you feel that you want to review the concept of pivot table, please free to watch these two videos. Okay, very simple videos. One will be an introduction to pivot table, and with this one will be more in pivot table. All right, so talking about the mini project. So I invite everyone to use the same data set. Okay, you have to go to this website. So the link is here. And then if you remember the other, I was a property tax roll data, right? So what I would like to do, I like ask you, just go with this police case log. Okay. So again, police case log is in Providence only. for the past 180 days. Okay. So whatever the case that they have recorded, they have updated here. Just go here, export the data as a comma separated value file, and then save it as Excel and start doing the analysis. Pretty much, I believe this data is almost clean. You don't have to involve in any data cleaning, I believe. So look at the data. The data will pretty much look like this once you download it. Okay. So you have the case numbers, you have the location where the case has been filed and the reported date. Let me take a couple more minutes. Okay. Please. And it's a past 180 days, right? So month, year, you have the same almost. But if you narrow down with the date, how many cases has been filed on 9th, how many cases on be filed on 8th, like that you can do analysis. Just I'm giving a clue on which date maximum number of case has been filed. And then here you have various offense, vandalism, burglary. You can group this in pivot table and you can see which has the most case filed in robbery or trespassing, like that you can, yeah, or motor vehicle theft. You can talk about that in the class. Okay. So just giving some 2 to 3 questions, you can come up with as many questions as you want. If you with the 2 questions, that should be fine. Yeah. And then the reporting officer, which means the officer who take in charge of this one and then recorded this. Which officer has most case recorded? You can go with that analysis, right? Which officer has the most case recorded in the past 180 days? Yeah, that should be one question for you. Just go ahead and then just try to, all that I want to is just whatever we discuss in pivot table, try to do that analysis in that. Let's see if you can answer your questions there. Okay. And then show me in the next class whatever you did. Okay. Yeah, that's totally fine. So this will be a kind of mini project that give you some hands-on experience before you jump into a real project. Okay. So this is a little thing that I want to talk about. All right. So this nice fine data, just go here, export, and then download it. Okay. So let's close this. So I will share the link and everything in Google Classroom tomorrow. Let me